In this video, we're going to go over some calculations for percent concentration. So here are the equations for percent concentration. I do not give you these equations. I actually don't give you any of the concentration equations, so you can either learn them or you may write them on your 4x6 card that's allowed. If we were in class, I'd pause for a moment, so I encourage you to pause and look at these three equations. I want you to see if you can figure out what's similar and what is different between these 3% concentrations. And one thing, I just noticed that this particular screenshot missed some of the features in the slide, so I'll fix that. All right, so go ahead, pause, see if you can figure out what's the same and what's different, and then I'll go over it. Okay, so hopefully what you discovered was the same is that they, on the top, is always the solute. So in percent concentration, we're comparing the amount of solute to the amount of solution on each one of these. That doesn't change. And then because it is a percentage, they're all multiplied by 100. So that part is all the same. Now what's different is what is being compared. So we have both the use of volume and the use of mass or weight. So if you look at the first one, it's comparing the weight, which is mass, and that's in grams, to the volume, which is V, and that's in milliliters. If you look at the second one, it's the volume to volume percent. So that's comparing volume, which is in milliliters, to volume. Whoops, that was something weird happened with all those lines. Let me get them off. My hand must have hit something weird. Sorry. I try to be efficient. The volume here, which is also milliliters. Excuse me. And then the last one compares the mass to the mass or the weight to the weight. Don't let the use of, if you see an equation that uses M instead of W, that's okay. One of my textbooks uses W and the other uses M. So here, weight, which is mass, in grams. So they all compare the solute to the solution times 100, and whether they're comparing the mass or the volume will depend on which percent concentration, which is told to us. Like, we don't have to make it up. They'll say, oh, using the weight to volume percent. Like, they'll tell us what we're comparing. And so a big takeaway here is when we see weight, which is referring to mass, those units are always going to be grams in this concentration unit. And when we see volume, those units are always going to be milliliters. Okay, so that's something for us and the concentration units we will encounter that are percent concentrations. They will have the units of grams and milliliters. So I have 3 different problems for us to try. 2 of them calculate the percent concentration, and the last one gives us the percent concentration and asks us to calculate the amount of solution. So here's the first one. It says a commercial mouthwash contains, so it has 4.3 grams of ethanol and 0.021 grams of antiseptic, and it's all in a 30 milliliter portion of our solution. Okay, so they give us some information, and what they want us to calculate is the weight to volume percent of both of the components. So if we think about the equation, the percent weight to volume, weight is mass in grams. So it's the mass in grams of the solute. Somehow my recording turned off. So if it seemed like a little it discontinued a little, that's why. The volume is going to be in milliliters, and that's the solution, and then times 100. All right, so we're going to have to do 2 of these because it asks for both components. So first, I'm just going to do the ethanol. And so its weight to volume percent. The mass of the ethanol is 4.3 grams. It has 30 milliliters of solution times 100. And so if I say 4.3 divided by 30 times 100, I get 14.33333. I'm going to just keep 14 for 2 significant figures. They don't write the grams and the milliliters. Instead, they put a W or an M and a V. And that's how people would know that you're comparing mass to volume. So the units don't really cancel, but they also don't include the traditional grams and milliliters there. They just write WV. So that's how much ethanol we have, 14%. And then the second one is antiseptic. And so the calculation is going to be the same. This time we only have 0.021 grams of the antiseptic. It's in the same 30 milliliter sample and times 100 for a percent. And I get 0.07 on my calculator, but I want 2 significant figures, so I'll add another 0. It would change the significant figures, but not the overall value. And that is also percent weight to volume, but this is the antiseptic. So that is the concentration of those 2 ingredients in this particular mouthwash sample. So notice, to figure out the percents, they had to give us the amount of solute and the amount of solution. So let's go ahead and try another one. Okay, so this gives me 1 ounce of lemon extract. Okay, so there's my solution, and it has 24 milliliters of ethanol. There's my solute, and this time they want the volume percent of that ethanol. So the percent volume to volume is equal to the volume, which is in milliliters, over, volume of the solute in milliliters, divided by the volume of the solution in milliliters times 100. All right, so I see something pretty quickly that this is ounces. It's not milliliters. So before I start, I have to convert the ounces to milliliters. So to convert, you have to know the conversion. It's 1 fluid ounce equals 29.6 milliliters. All right. So this one we really wouldn't have to do anything because it's 1 ounce is 29.6. But if you didn't have 1 ounce, remember you take what would be given, so that's the 1 ounce, and then you multiply it by the conversion factor. So if you didn't have 1 ounce, this number here would go right there. And then you multiply it by 29.6 and you'll get your volume. All right, so let's plug it in. The percent volume to volume of the ethanol, we have 24 milliliters of ethanol in 29.6 milliliters of our solution. And so 24 divided by 29.6 times 100 is 81% volume to volume. So in this particular lemon extract, the concentration of the ethanol is 81%. All right, so let's look at one more. That makes me want to look on the back of my like vanilla or almond extract or something I have in the house and see if they report the percent alcohol. Now I'm curious. I'm not going to do it now. I'll do it after I stop my video. All right, so we have one more problem, and this one's a little bit different because it gives us the concentration. So it says a drink sold in a health food store contains 5% vitamin C. So it gives us a weight to volume percent. And it wants to know what volume would you have to drink. So how much of this solution to get 1,000 milligrams of vitamin C? So I can still start with the equation, percent weight to volume equals the mass of the solute that has to be in grams divided by the volume of the solution, which would be in, oops, I don't know why my pen keeps messing up. Solution in milliliters times 100. Okay, so let's see what I know. I have the percent, so I'm highlighting it there. That number is going to go here in the equation. I have the amount of vitamin C, which is the solute. It's going to go here, but this one's in milligrams, so I'm going to have to get milligrams into grams first. And then what I'm going to solve for this. So before I do that, I need to convert milligrams to grams. And I know that there are 1,000 milligrams in 1 gram. So in this particular case, 1,000 milligrams would be the same as 1 gram. There's no decimal there, so I'm guessing it's to one significant figure because that's what it looks like to me. If it wasn't 1,000, you would take the number of milligrams you're given and then you divide it by 1,000. So you would take, see if I can get a different color marker so you can see what I'm talking about. You would take this number, whatever that number was right there, and plug it in right here. So if that was 750 milligrams of vitamin C, you would plug in the 750 and then divide it by 1,000. Okay, so let's plug in. I know that the percent concentration is 0.50. Okay, so I'm plugging that. That's going to equal 1 gram over a volume of my solution. I'm just going to write the letter V for volume. Times 100. Don't forget the times 100. Now, to solve for this, you might pause and just go ahead. What you're going to do is you're going to solve for V. I'll show you one way that I would do it, but you're going to have to solve for V. So V is in the denominator, so I'd have to multiply it over to the other side. Then I would get V times 0.50 equals 1 gram times 100. And I will tell you, you know I love units, but since these don't really use units, like they just tell us up here percent weight to volume, it's a little easier to take them out. So now I have V times 0.5 equals 1 times 100. Well, 1 times 100 is 100. So I'm going to divide the 0.5 over. So V equals 100 divided by 0.50. So that would equal 200 milliliters. So that is how much I would have of this solution to drink, 200 milliliters of solution. Which on our previous problem, let me see how many ounces that is. So 200, remember it was 29.6 ounces. Oh, it's only about 6.7 ounces. So it's not even a cup. 200 milliliters sounds like a lot, but it's not even a cup of liquid. So anyway, so that's how you would solve it. So you might need to think about the math part, but just so you know that you can solve for either the top number or the bottom number if they give you the right information. And do not forget, the most common mistake here for students is they forget this times 100. Don't forget that. They drop it off. Okay?